In terms of this type of adaptive reuse projects, I truly think it's one of a kind. I don't think there's many high-rises building in the world that have been sliced in half vertically and rebuilt, adding floors and completely changing the shape. So it was an incredible challenge, including the fact that, you're in the middle of a very, very busy CBD, and people are walking by and looking up and asking themselves what the hell is going on this building.
Quay Quarter Tower is one of Sydney's most remarkable transformations. What began as the AMP Centre back in the 1970s has been reimagined into one of the world's most sustainable and architecturally ambitious towers. Today, Quay Quarter Tower stands as a symbol of adaptive reuse, preserving much of the original building's core and structure while redefining how commercial towers can evolve for modern life. Joining me today are Leonardo and Xiaoyu, who are both part of BG&E's team on this incredible project. Guys, I'm so excited to have you here. I would love for you to introduce yourselves before we get started.
Hello.
My name is Xiaoyu, and I am a senior structural engineer at BG&E. So I joined BG&E about almost 8 years ago, and as a graduate engineer, so I basically grew up in BG&E, and QQT was my first project, and I was the resident engineer on site for 2 years with Leo to start with, and then Leo abandoned me on site. That's pretty much it about me.
Yeah, I'm Leonard, and I have been with BG&E for almost 12 years now. I'm currently a senior associate in construction engineering and lead up in the Gold Coast office. I was in the Sydney office for almost 10 years and then moved up to the Gold Coast office because I moved in the northern side of the New South Wales. And I come from originally Italy and half French as well. I did my bachelor in Rome before I moved to Australia. I joined BG&E after working for 2-3 years for a smaller structural engineering consultancy in Sydney. And here I am today.
If we were to give a little bit of context to our listeners, people that live overseas and are not familiar with the Sydney skyline, how would you define QQT?
Well, it's definitely a iconic building, I'm saying, like both from the look of it, the architectural beauty of it, and also from all the designs and sustainability initiative behind it. So if you look at it from actually every day when I come to work, my bus just drive across Harbour Bridge, and then I can see the building, and then I just can't stop being amazed by the building. That's how I feel. Like it's such a beauty to me.
Yeah.
And also it's like a lot of creativity from engineering perspective. So like it's really rewarding to know that I have a hand in it.
Yeah, absolutely. Being part of something. And I think that's like one of the most rewarding things about the profession. But yeah, Leo, your turn.
No, I guess like to contextualize, to answer your question, it's located in Sydney in Circular Quay, which is a very touristic area of Sydney. It's right in front of the wharfs of Circular Quay, and it faces the Opera House, the Harbour Bridge. So it's right there in the first line, looking north towards the Opera House and the Harbour Bridge. So it has, I don't think you can get any better than that in terms of views. If I'm not wrong, I think someone said to me once that it's the per square meter most expensive commercial real estate in Australia. So yeah, that's the context. And then obviously it has a very unique design in the way the building is made out of 4 or 5 blocks that twist as they go up, and it starts looking towards the west, towards the Harbour Bridge, and then as it goes up, it spins towards the east, more towards the Botanical Garden. The idea that was behind the block spinning and leaning more towards the northeast was also to provide less shade on the Botanical Garden. There was probably other criterias that defined the shape, but yeah, there's this idea of the vertical village where
Yeah.
all these blocks are united by a common big atrium, and you can go up and down, and there's a connection between all these floors that pertain to that same block.
Mm.
So yes, there were a few to mention.
I think definitely the vertical village is one of the main concepts. Like basically they are encouraging the interactive workspace, like how to say reactions between floors. So basically you can within this big block of like say 10 levels, you can actually stand on the level below and then communicate and see people from the level above. So it's like quite rare in a high-rise
Connectivity.
building. Yes, but it's all before COVID. So I'm not too sure like how much the concept had come across during and after COVID. And then also the twisting, as Leo mentioned, is basically to, I think, to maximize the view as well. So it's like it comes from, it also has a functional perspective in terms of the facade and saving the energy and then providing shade as the sun goes up from east and comes down to the west. Like the facade panels actually changes in shape around the building. But the twisting is basically, as Leo just said, like on the lower floors, you're actually facing the harbor where the touristy space, and you can actually see all this like pretty, like the rocks and the wharf, or the pretty streets and piers. And then as you go up, you're actually twisting around and to look more into Botanic Garden and have a better view, and then basically
Well,
also avoid being blocked by the building in
mm,
front of it. I think that's also a MP building.
yes.
Is it Alfred Street?
33 Alfred Street. Yeah.
Yes. So it's like basically by designing that you're like limiting the blockage of the view from the building in front of it as
Very well
well.
considered.
Yeah,
Yeah. Wow.
it's very
Very
smart.
interesting. Yeah,
Yeah.
very smart. And modern. I always wonder how they achieve that, because you start your project and then you finish so many years after. So it's
Yeah.
still relevant into, facade looking, and like it's still modern. So
Yeah.
that's always
Yeah,
been sort
that's
of
a good
like
point.
an interesting thing that I pick up on buildings.
To give the audience a little bit of an understanding is, so this is an existing 43-story tower that was built in the 1970, owned by AMP Capital. It was at the time one of the first high-rise in Sydney, and it's essentially a reinforced concrete building which has a square plan. It's got a central reinforced concrete core, and it has a series of perimeter columns, and every floor plate is very typical throughout the tower of what the existing building was. So it was a very well-known building in Sydney. AMP own that whole block, including the building in front of QQT, which is the 33 Alfred Street building, which, for instance, 33 Alfred Street is what is considered the first high-rise in Sydney, even though it's half the size of the AMP Tower. And so what we did to the existing AMP Tower is, first of all, we added, I think, 5 floors, because we've taken it to 50 floors from 44 or 45. We essentially demolished the front third of the building. So as if we basically sliced the existing building vertically. There was a cut line proud of the existing core, and we demolished the first third northern side of the building all the way down and rebuilt the new structure, doubling the floor space. So the footprint of the building is about twice to what it used to be. And the look has completely changed also, because the facade also has completely changed. So in terms of this type of adaptive reuse projects, I truly think it's one of a kind. I don't think there's many high-rises building in the world that have been sliced in half vertically and rebuilt, adding floors and completely changing the shape. So it was an incredible challenge, including the fact that, you're in the middle of a very, very busy CBD, and people are walking by and looking up and asking themselves what the hell is going on this building. So there was a lot of a lot of concerns and like attention on making sure the design was sound and the safety was sound and everything was going to plan. There, hence why this very strict monitoring regime that we had in place. So it's very unique from that point of view. So it's a real engineering challenge. Just to put it in perspective, BG&E's consulting fee for the project, which was X, half of it was temporary works.
Yeah.
Which is obviously very rare. So there was a lot of design involving stabilizing the building, demolition, creating voids, staging, working on multiple fronts, excavating a new basement in front of an existing 40-story tower. So yeah, there was a lot into one. So we are dealing with an existing 50-year-old building at the end of its life and wanting to keep a substantial part of it and recertify it for 50 years, you have to have a very confident level that, the existing structure is the strength, is behaving and is the way it is on the existing plans, right? We know there's always imperfections. So a lot of testing to validate the existing structure and its conditions and with regards to the durability for the next 50 years as well. So materials evaluation and testing, that was a big one. The other one that we also provided as a service, which was very important as well, is the monitoring of the building during the construction. So we had a series of different instruments that we used to monitor the behaving of the building in terms of its displacement, vibrations, accelerations, and things like that. And that allowed us to do two things. One, making sure everything is safe. So, okay, the building is settling and leaning and displacing as we have predicted in our models. So it's all good and safe. If it doesn't, then, we can put safety measures in place to understand what is happening. So one thing is understanding everything is behaving as per our predictions. Two, which was another big component of this project, is that because we have all these instruments, as we are constructing, we can use these instruments to refine our design parameters. We have real life data on what is the stiffness, the dampening, and we can feed those results back into our models and refine our design and do things like reduce the strengthening scope that we thought was necessary, or this sort of things, or understand if we really need a tune mass damper or if we don't, which we needed at the end. So monitoring was a big part of our scope. We were analyzing the data that we received from surveyors and all the monitoring devices, and then we interpreted that data, issued reports to the client, and monitored that throughout the whole life of the project. So we had survey targets at different points along the height of the building facade, and so every now and then you'd have a surveyor shooting with their machines the targets, giving us location positions of these targets, and then we would plot over time how the building is moving. There was accelerometers, there was inclinometers, there was strain gauges, which were used to measure the deformation of the concrete, and there was, last but not least, the
plumb bob.
The plumb bob, which is actually turned out to be the most accurate device on site. For those who don't know, a plumb bob is very simply a string that is hung at the top of the building that goes all the way down. It has a weight at the end, and it's like a pendulum. And if the building leans, the weight moves. And if you have a reference on the wall, you can look at how the pendulum has moved about that reference, and it's telling you exactly how much the building has moved at the top. It works perfectly, and the only problem though is that it gets damaged because it was in one of the shafts, the lift shafts of the building, and they had scaffolds and all sorts of different subcontractors doing their own things there. So it would work for a few months, and then all of a sudden you'd have
jackhammering around
happening, and someone knocks it over. So it was a pity, but yeah, that was definitely something we also used for a little while.
And in terms of the structural monitoring, I believe we had a PhD student working on that regime as well, and then pretty much it produced a PhD thesis. That's to provide a bit of a perspective of how big it is.
Wow, that is so interesting that this was part of someone's thesis. I didn't know that. There you go. You learn something every day. And another thing that I really want to learn from you guys is, what were some of the main challenges that came with designing a project of this scale?
I think the uniqueness of it is like in terms of construction sequence is like normally when you do demolition and rebuild, you do top down demolition and then bottom up construction. But what happened at QQT, it's like a optimized construction programming and sequencing, and actually the demolition and rebuilding were happening at the same time. And also there are like, basically as Leo says, there are like different construction stages, like all happening up front, happening at the same time. And that again link back to how we monitor the building and how we basically refine and modify our model real timely as a construction happens. So that's the real like special part of the construction to me. Like as a structural engineer, I actually worked really closely with the builder, like just going through iterations of changes from the monitoring data from site, and also we real timely adjusting the construction sequencing and then feed it back into our model, and then run the model, produce basically the structural parameters prediction based on that structural construction sequence. So it's like a real quite comprehensive way to look at the building dynamically. I think Leo will have a lot more to talk about the construction sequencing.
Yeah. No, I mean, look, if I need to maybe spend a few minutes on the, I guess, main structural challenges from a permanent design point of view, there was a big challenge in considering the time dependency of the design into the equation, because when you build a new structure, it shrinks, it creeps, it moves over time. Now, if you're building a new building from scratch and you build progressively up, there's movements that are associated with the building shortening as it elastically shortens under its own weight, which is something that is a bit more noticeable with high rises. So it's not an issue when you're building a new building from scratch, because everything comes up together and comes down and shrinks and elastically shortens, and everything shortens to the same amount. Now, when you have an existing tower that you're trying to stitch a new building against, the existing tower has already shrunk. It's already shortened because of its own weight. So it's there and it's not moving. The foundations that are also elastic, the rock is elastic, the weight is all there. So it's already there. It's not moving. Now you're trying to stitch a new structure, which is going to shrink, creep, elastically shorten. That means that every level that you build, for it to match with the existing level, you actually have to build it higher. Now, there's a whole exercise, which was very complicated engineering, which was associated with predicting what these movements were going to be, so that we could build the new structure in the right location, such that over time, as it's going to move and shrink, it can then be matching where the existing structure is. The other thing that was very challenging is that, like we mentioned, we were stitching a new core against an existing core. So drilling bars and pouring and extending an existing concrete core. The existing core is there. It's still, it's shrunk, it's creeped, it's not moving. Whereas the new core, as you're pouring it, wants to shrink. And that force wants to drag down the existing core, and it actually turns into really, really high stresses applied to the existing structure. So managing these stresses applied from the new core to the existing core, it was something that was also a very significant challenge. Not to mention all the cantilevers, which, it's not a cantilever that is symmetrical. It's a cantilever that is more pronounced on the west side. So the building not only wants to lean under its own gravity, but it also wants to twist. You've got a very big offset between the stiffness center and the center of mass of the building. So under wind and dynamic effects, there's twists and vibrations of the whole building that had to be managed. And this is why then at the end, the call was made to have a tune mass damper at the top of the building. So there was a huge effort, Reza, who was one of the key BG&E staff behind the stability design of the building, had to build a NETABS model, which was not a model set in time. He had to build a staged construction into the model to take into account all these long-term effects. You just couldn't have designed it without taking those effects into account. So there was notable challenges from the design perspective of the permanent structure, and then there was just as many design challenges from the construction point of view in terms of all the engineering that was behind the construction. And that included, like Xiaoyu explained before, all the staging, the sequence. How do we deal with all these different activities that the builder wants to do at the same time? They wanted to they demolished the gut of the building to build the core from the inside. At the same time, they were demolishing the top of the building. And at the same time, they were starting to build what we call the jumpstart structure, which is the new extension of the building, had its own, floor plates and columns. That was coming up as a separate building until the demolition from the top would reach the point where these two would cross over, and then you could start building the new structure back to link with the existing building. So for 10, 15 floors, we had the new structure that was a separate building, essentially, that had to have its own temporary bracing, stability system, and so forth. Huge cantilevers up 100 meters in the air. How do you build a floor that's cantilevering in the void? You have to build a platform underneath it. So that platform has to cantilever really far from the last floor you've built to be able to provide a working platform for the large cantilever that you're building. Like I could go on and on, like the building because of its shape, has like raked columns and hanging columns, and to be able to build a floor that's suspended off a hanging column, you have to build a support for the top of that hanging column, which is further like 10 floors above, which you haven't built yet. So there's temporary supports for that. And there was extremely complicated construction sequence. And this is why we needed Xiaoyu full-time on site. There was, I have some statistics here that I pulled out of one of the presentations we did. I think we had, what was it? There was 70 structural engineers on the job, not at the same time, but throughout the history of the job. I think there was a team of 16 all at once at the peak. There was 39 drafters all up. We produced almost 1,000 drawings in total. I think BST said that we've booked 90,000 hours as a company on the job. So it's huge. Yeah. Really, really significant.
Wow, an incredible amount of work went into this project. It really highlights the scale of how big this was. And with a site that complex, there were some unique constraints to work around too. Is that right? Remember how we were talking about some of the tricky conditions the site had that you had to take into account?
So the site is crossed by one of the first sewer that was built in Sydney. It's called the Bennelong Drain, and it's heritage listed, and it's a heritage listed asset that is managed and owned by Sydney Water. And there was a lot of pressure on this asset because the building next door had 3 or 4 months delays in construction because the team there couldn't satisfy Sydney Water that they were protecting the asset well enough while the construction was taking place. So there's essentially a big oviform brickwork sewer that is about a couple of meter high and 1.5 meter wide or thereabouts. And it literally just crosses the site east-west. And we had to make sure we stabilized the sewer because we were excavating right adjacent to it, another basement level. And as we know, as you excavate in rock, the adjacent rock relaxes and tends to move. And that can cause cracks and damage in a sewer, which is made of masonry, which is stiff and brittle. So we had to prepare a very lengthy report with numerous versions to submit to Sydney Water. And I went through this process, and we also had to go and present our design and how we were bracing and protecting the sewer to make sure that it wasn't going to be damaged. We got one of our masonry experts involved, Clive Allen. He did a whole final element analysis of the sewer against cracking criteria, I guess, satisfied Sydney Water that we were doing the right thing and we were going to not damage it. So it's interesting because it's the first sewer in Sydney. Before that sewer, I think people used to throw their stuff out on the street. So it's quite a, I think it's from the initial 1800s. I'm going to get in the details, but yeah, it's a very significant piece of infrastructure. I couldn't always say that being from Rome and growing up in Rome, where you've got, things such as the Colosseum. And for me, I couldn't understand how 150-year-old
Historically.
masonry tunnel could have any historical significance. But anyway, that's just,
But there you go.
Just a joke.
There you go.
But I didn't tell that to Sydney Water.
No, please, they're listening. No offense, please. Xiaoyu, you mentioned one when we were talking about the architectural element of the building about COVID. Like this building was happening during construction. Was it COVID times? How did that impact the team?
They just never stopped, to be honest. As in, for our design engineer perspective, like in the office, we apparently went through like lockdown, and then everyone worked from home, and then it's like try to figure out with all the VPN stuff. But like our team, to be honest, never really stopped servicing, like provide the quality service.
Yeah.
But then on site, apparently, I don't think any builders actually stop they have the exception from the lockdown. So actually because I was on site at that time, actually I felt it was busier than before COVID because there was nothing else to do. So you just go to work very early and work for 6 days a week. But there was quite interesting period because there was the requirement of like everyone has 2 meter by 2 meter like area in the office, and then we were in multiplex office, and then like they were basically rearranging the whole office, making sure everyone has enough space from each other. And then they realized they don't really have that much space in that office, so they had to kick me out. I remember I was like given a little box and then put all my stuff in, and then walked out, and I was like, oh. I remember calling Leo on my way home, and I was like, Leo, I feel like I was fired. It was like really sad
we don't
somehow.
have space, bye. You're like,
right. They're like, we need to take care of our own people first.
Yeah.
And then that was like, they only lasted for 2 days because Leo was like, okay, you don't want our engineer to be there. I guess we can only do FaceTime inspections. We did a few video inspections and then realized, oh, it's not working. And then like they brought me back.
Absolutely. It seems like it was a very hands-on project. You were saying at the start, like you were basically on site more than in any other project that you see. So maybe they were struggling with the FaceTime. So they had to bring you back. Oh, that would have been like, what is it? The walk of shame?
Yeah, I know. I was like, because our office was at the like a corner, like an inside corner of the multiplex office, and then we're just like basically taking my little box and walking out through the whole crowd. It was pretty interesting,
especially at the start of your career. You know, like there's so many things that we do when we start our career take a little bit more personal than others. I don't know. Obviously, like looking back,
it that personal.
You're like Leo. But anyway, it happens. It happens.
It was difficult. It was a very difficult time. I mean, I remember it as one of the toughest times of my career, maybe, because not only we were in this obvious, very concerning historical moment where no one's been through that before. But also for me, at least, it was probably the busiest part of the project because I don't think I've said my role on the project yet, but I started like as a full-time site and / temporary works designer as well. I was heavily involved in the temporary works as well. And then about halfway through, which was about when COVID started, the lead of the project, that is not with BG&E anymore, John Van Rooyen. He quit BG&E, and so I was given the role of project manager. And so all of a sudden there was a pandemic going on. I was managing the job, and there was still like half of the tower to be built, and some of that design still was being issued AFC. So I was literally up from, I'm in a situation where you work from home. I was literally rolling out of my bed, sitting on my desk, and then rolling out back into my bed, working 12 hours a day, including some weekends every now and then, with a very demanding and at times stressed client. So it was tough. I remember it as a very tough time. Even personally, there was one of my flatmates, one of my best friends, that was going through a bit of a mental journey, and due to COVID as well. So it was tough. I think it was a tough period, but I think we kept it all together somehow.
And that's right. And during COVID, I think that was the very difficult thing, like setting up boundaries, because our workplace was our home. And that was something that organizations before were trying to work towards, have like a hybrid sort of thing. But it was a very non-familiar term for a lot of organizations in comparison to what it is now. So I in a project where there's a lot going on, I can imagine how that would have been a combination of a lot of stress.
Yeah.
To wrap up, what I wanted to do was those rapid fire questions. And it was sort of like about your experience and how, this project shaped you. And I think we sort of like went through it a little bit, but what is sort of like the before and after of having worked in that project for your professional careers, guys?
So for myself, again, I feel like extremely lucky. This is my first project because before I joined BG&E, I was like, I finished my PhD degree, and then I was like doing research assistance at uni. And then I was like, I actually really want to do something more down to the earth, more practical. And then this one as my first project, and actually being on site to see things happening, things getting built, that kind of like firmed my decision of being an engineer. So that was, I feel like everyone has a few points in their career when it kind of like form a type of like engineer you are, and also, or whether make you decide, okay, this is what I want to do for the rest of my life. So that was a moment I was like, I'm so happy with the decision of coming to the industry and actually, see how it's happening. But then like for me also, as a very junior engineer working into a construction site and spend the whole time basically with builders, I think for my own career development, the most that taught me is actually to think about the constructability or buildability in your design, because there are so many times on site we have the drawings and then like the builders would be like, or I just get yelled at, basically. They'll be like, if you can put this caging, I'll do it for you. And then I look at it, I'll say, yeah, you're right. Like, we actually didn't think about how to build it on site. So I would say, like, I think every young engineer should have a sting on site. It's just so much help for the practicality of your design. And it's not only just about numbers and making sense in the model. It's about like visualize it and think about how they do it on site. Yeah, I think that's
absolutely. Constructability is a big one that we don't consider too much in the office. You probably do, Leo, all the time.
Yeah, construction team.
What about you, Leo?
Yeah. No, first of all, I'm very, that Xiaoyu was, of her words, and for me, it's been very, very nice to see her progression, and actually witnessing what she just explained, how for her being on site, I think allowed her to pick up things very, very quickly and make less mistakes, or just think the design through a little bit more because of the knowledge of how things are actually happening on site. It means you put the time in the right place. Some details, they're not that important. They're going to be very hard to get perfectly right on site. So there's no point wasting your time on that. So yeah, it was very nice to work with Xiaoyu and see her grow and see where she is now. Mm-hmm. For me, I think that was definitely the highlight of my career, engineering career. I could have probably retired after the project and I would have been happy. So I feel extremely privileged to having been part of the team. Look, it was just an incredible source of learning at so many different levels because the project touched really everything, groundworks, excavation, composite slabs, monitoring, testing, durability, working with contractors, temporary works, construction engineering, thinking how you're actually going to build something that hasn't been done before, right? Nothing is conventional about that building and that construction sequence and staging. So yeah, look, I love human contact. So for me, being on site with the contractor, working with them, sitting down every day, talking about how we're going to fix the problem, it's very, very rewarding. You see it happening
Absolutely.
right in front of your eyes. And to me, it sort of solidified my passion for this aspect of engineering or construction engineering. How do we put our engineering hat and really, I guess, try to find the smartest way to build something easily, quickly, with less cost possible, and logistically that works well with transportation, easily assembly, easy to put together, considering all the constraints. You're the architect of your own work when you do temporary works. You're the one deciding the shape and the best, most efficient way to design a structure. It kind of solidified my passion for that aspect of engineering, and I guess from there, I think that's also the turning point in which BG&E put in place an official construction engineering discipline within the business. So, and I was, part of the birth of that. So yeah, there was a
significant
significant turning point. Yeah, before and after.
Guys, any advice for you younger selves when you were going through that?
If I was gonna say something to my younger self, I think would be confident and don't be afraid of asking questions. I feel like being curious is like the best way to learn quickly.
Try to keep the emotions off the work. There was a part of the project where I started project managing the project, and I was also dealing with commercial things, variations, complex and tense meetings. And I think I always remember Graham Reed's words, one of our BD guys in Sydney, a great guy. He always used to say, whatever you say, it's not personal. It's business, So don't take it personal, and don't think that people will take it personal. So yeah, I guess that was, I think, maybe one thing that I wasn't really good at. I always put the passion in and the emotion. So I think that's a good thing to leave aside sometimes, to know how to do it at least.
I love that.
I would say that to myself.
Guys, thank you so much for this time. I've really enjoyed learning much about QQT, and I hope our listeners also learn the involvement we had and more about our people that, shaped that project. Thanks for tuning into the first episode of our podcast. In the next episode, we'll sit down with one of our graduates to talk about what inspired his path into engineering and his experience building a career here at BG&E.